Hey everybody, it's Jay from Norman S. Wright. In a lot of my videos, I talk about ventilation and airflow, but when I talk about humidity, it's mostly about cold, dry air coming in from outdoors or the humid, warm air in the summer that's coming into your system. But humidity is very important for your indoor air quality. So I want to talk about humidification some, but first let's talk about some humidity basics. So let's get started. Let's start with air. Air is a gaseous mixture of nitrogen, oxygen, carbon dioxide, water vapor, several inert gases, and traces of ozone, and some submicroscopic solid matter. For HVAC purposes, though, air is considered to be made up of dry air and water vapor. The water vapor part is the humidity. The properties of the dry air is pretty much unchanged as temperature changes. The water vapor, on the other hand, can change a lot as temperature changes. These changes can include changes of state, condensing or freezing, and lots of energy is involved when these changes happen. So let's make some room. Most often when we hear humidity discussed, they're talking about relative humidity, RH. Relative humidity is the amount of moisture present in the air at a given temperature compared to what the air could hold at that temperature, and it's shown as a percentage like 65% relative humidity. As air temperature increases, its capacity to hold water vapor increases. So at 30 degrees Fahrenheit, the capacity to hold water is lower than at 50 degrees Fahrenheit, which is also lower than at 90 degrees Fahrenheit. So these water drops represent the total capacity of water that temperature air could hold. At 30 degrees Fahrenheit, it would be 100% relative humidity. At 50 degrees, maybe that's 50% relative humidity, and at 90 degrees, that's maybe 30% relative humidity. Then there's also absolute humidity. Absolute humidity is the amount of water vapor present in the air regardless of temperature. It's measured in pounds of water vapor per cubic foot. Unlike relative humidity, absolute humidity doesn't change with temperature. Think of it as the volume of the light blue color areas above that I just drew. Absolute humidity can also be measured in grains of moisture. Let me make a little bit of room here. 1 grain of moisture equals 1/7,000th of a pound of water, so 1 pound of water is 7,000 grains. Grains per pound of dry air is used because it provides a finer resolution when measuring humidity changes. So let's make a little bit more room. Humidity ratio, also known as mixing ratio, is the mass of water vapor per unit mass of dry air. So humidity ratio W equals mass of water vapor divided by mass of dry air. Specific humidity is the mass of water vapor per total mass of air. So specific humidity Q equals mass of water divided by total mass of air. Because the amount of water vapor in the air is usually very small, humidity ratio is approximately equal to the specific humidity. So those are the humidity terms you're likely to see. Let's cover a few more terms that are humidity related that might come up. Let's move this over for those. The first is dry bulb temperature. This is the temperature measured by a standard thermometer. Then there's wet bulb temperature. This is the temperature measured by a thermometer covered with a wet wick. If you see someone using a sling psychrometer, this is what they're measuring. There is a wet wick thermometer and a standard thermometer for comparison. As the water evaporates from the wick, it cools the thermometer, and the temperature reading reflects how much the air can be cooled through evaporation. The drier the air, the faster the evaporation, the greater the difference between the dry and wet bulb temperatures. And move this up again. Next is dew point temperature. This is the temperature at which air can hold no more water vapor. In other words, it's the surface temperature at which moisture will begin to condense on a surface. The more humid the air, the higher the dew point temperature. Next, we have latent heat. This is the heat that results from a change in the amount of moisture held by the air. It's the amount of energy needed to cause a phase change, like from liquid to gas, or vice versa, without changing the actual temperature. Make a little bit more room. And then there's sensible heat. This is the heat required to change the temperature. This is the temperature sensed by a standard thermometer. So let's bring all those terms back on screen. That should cover the basics about humidity. Next week, we can start talking about humidity control and humidification. If you have any questions or suggestions for future videos, put them in the comments below. Don't forget to like and subscribe to our YouTube channel. Thanks for watching, and I'll see you next week.